Cases when limit does not exist. Now, there are many cases where we can't say the limit exists. We have to say the limit does not exist. And the most often case that you see is when the left limit and right limit do not agree. Then the limit does not exist. DNE is for limit does not exist, and a more technical term for it is diverges. Okay? If the left limit and right limit do not agree, then we say the limit diverges. This type of DNE, or this type of divergence, often happens when you have a function that is defined piecewise. Well, sometimes even piecewise functions do have limits, but in many cases when you have a piecewise function and 2 is like the boundary between the two definitions, it could be that they have a jump discontinuity like this. So as you go from the left, the limit goes to 2, whereas if you approach 2 from the right, the limit goes to 1. So in this case, what we have is that the limit of f of x as x approaches to 2 from the left, that gives you 2, whereas the limit f of x as x goes to 2 plus, the limit is equal to 1. And since the left limit and the right limit, they do not agree, we say that the limit of x going to 2 of f of x does not exist. Now the second case where limit does not exist is when left or right limit goes to infinity. Then the limit does not exist. A very easy example of such is this graph here, y equals to 1 over x. As you know, this is what we call the hyperbola. One goes up like that, the other goes down like that as you approach 0. So in this case, what happens is if you take limit of 1 over x as x goes to 0 minus, that's approaching to 0 from the left side. So as you go left, you follow this curve and you see that you go down, down, down. That's negative infinity. Whereas limit x going to 0 plus 1 over x gives you, well, if you approach from the right and you follow the curve, it goes up, 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 so it's positive infinity. And as you can see, if any of these become infinity, we can say that the limit x going to 0 of 1 over x does not exist. To emphasize the fact that you only need one part of the limit to go to infinity, here's another example. I know many people don't like piecewise functions, but here's a piecewise function where it's 0 on the left, and when in the positive side, the graph is like 1 over x, the previous one that we just drew. In that case, the limit of x going to 0 minus of f of x, you're following here, so it's 0. Whereas limit x going to 0 plus of f of x, you're following this way, so it's going to positive infinity. And in that case, because of this, we can say that the limit does not exist. The limit does not exist. Okay, now here is another example. You have 1 over x squared. In this case, you see that the limit going from the left is positive infinity and the right is also positive infinity. And since both left and right limit is positive infinity, we have a situation where the limit does not exist, but you can be more specific. Having the limit going to positive infinity is a case of divergence. So technically saying DNE is not wrong, but if you can be more specific and you can say that the limit goes to infinity, then you should write that instead of DNE. So you should write limit x going to infinity of 1 over, not infinity, x going to 0 of 1 over x squared is equal to positive infinity because the left and right limits both go to positive infinity. Now this last case is something that you wouldn't see often, so you just have to know that such a case does exist. Here is some strange function, f of x sine equals to sine 1 over x. It's not that practical. You wouldn't see this in a practical setting. But theoretically, you could have a function like this. And it's a very weird graph because, let me show you the graph. Here's an online graphing calculator. So here I drew sine of 1 over x here. And if I go in, you see what's happening is the graph goes like this and goes up, down, and the cycle of going up, down it goes up, down more rapidly, right? So as you go close to 0, this goes up and down so fast that it doesn't get close to a single number, because when you have a limit going to a single number, it means that the value becomes closer and closer to a single value, right? A target value. The value of the function gets closer and closer to a target value. But in this case, it just oscillates, and therefore it doesn't become stable, and it doesn't get close to a single value. So in this case, the graph oscillates wildly, and this is just one example you just have to know. So to review, there are 3 cases where you can have limit does not exist, and the most important case is when you have left limit not equal to the right limit, and the second case is when you have either limits going to infinity, and lastly, if the graph oscillates wildly, then the limit does not exist.